This is video 1.2b of Pre-Cal 11. I'm not going to, I don't want you to look at this, this part here. That's just a single calculator. Um, I think I went through and ask me in class for help with that because there's a couple different ways that calculators work, and that's just one specific calculator. Okay. This next part, it's actually really important that you do this because it's really important you can use your calculate to do these evaluations. There's a couple of different challenges that you run into when you're using a calculator, and so now's a really good time to figure out how that calculator of yours works, okay? So pause the video and then come back and check your answers. Here are your answers. Just a couple of things that I do want to point out. One is that my calculator gave me an error message on this one. My calculator won't let me take any root of a negative number, even though it does exist if it's an odd root. So I have to put it in as a positive. I have to do the seventh root of 2187, and then just myself know that that is going to be negative. So that's something that you might have run into with your calculator. And the other thing is that this one, because we are just using our calculator, you maybe have got 1.2 on this, which is correct, except because this is a fraction question, I will normally expect a fraction answer on that. That's just a convention that we usually follow in math. If there's fractions in the question, we expect fractions in the answer. Unless, for example, in this next set, you're asked to evaluate to the nearest hundredth. Clearly there we're looking for a decimal approximation with 2 decimal places. So pause the video and go ahead and see how you do. Okay, there's your answers. If you didn't get them right, try again. Make sure you figure out how your calculator works because, like I said, they're all a little bit different. Okay, now we're going to move on to radicals. So numbers like root 30 or the cube root of 125 or the fourth root of 15, these are called radicals. And anything in any expression in the form that looks like this, where this little piece here, which is called the index, is a natural number. That's what this means. This right here, this means n is an element of the real number system. So n is an element of the numbers, or sorry, of the natural numbers. It just means it's a natural number, 1, 2, 3, 4, 5. It's not negative, and it's not a fraction or a decimal. So n is called the index, and when we just write it like root 30, there is an assumed index of 2. But mathematicians are lazy and we don't write anything down that we don't have to. So if there's nothing there, you just assume that it's 2. All right, and here's some vocabulary that you definitely need to know. The sign is called the radical sign. The part inside the sign is called the radicand. And the little number up here is called the index. One thing that I will caution you about is when you're writing things like this in your work, make sure that you clearly know which part is the radicand and which is not. I often get things on tests written that look like this, and I don't know if that is the cube root of 2 times 9, or is it the cube root of 29? I can't tell when it's written like that. So what I'll usually do in my own work is I do that. I make sure I extend it, and then I put a little tick mark going down that says, okay, this is where this actually ends. So there's no ambiguity or confusion about what is under the radical sign and what is not. The whole thing together, the whole thing is called a radical. Okay? So that's important to know that vocabulary. And then, like it says here, the index is how many times the radical, like the result of it, has to be multiplied by itself to get the radicand. So, for example, the cube root of 8 says that I'm looking for what do I need to multiply by itself 3 times to equal 8. Okay, actually this should be an arrow because that's not an equals, but I'm looking for 2 times 2 times 2 equals 8. So the cube root of 8 is 2. All right. Okay, one more page. We're going to identify the index and the radicand in each of the following. Um, Pause it for a sec. I'm just going to do one and come back and check it. Okay, and pause it and I'll do the next two. Okay, so the index is always that little number up here. Oh, the index is the little number up here. Here there isn't one, but we assume it to be 2. And here it's the 3, okay? And the radicand is what is underneath the radical sign, inside the sign, inside the sign. That's the radicand, okay? And there's another part on this one, which is this 5, and this is the coefficient. And the coefficient is basically whatever you're multiplying something, a variable or something like a radical or something, what you're multiplying it by is called the coefficient, okay? All right, and now we have some review. This is from a question that you had in assignment 1 or lesson 1. This is also a review from last year that the square root of or did we do this last year? We didn't. We did this with exponents last year. Right, that makes sense. So we know that 9, let's just do another example up here, like 3 cubed times 3 to the 5 equals 3 to the 3 plus 5, which is 3 to the 8. So this is a similar rule that you can take the square root of 9 times the square root of 4, and that equals the square root of 9 times 4. Division, same thing, square root of 9 divided by square root of 4 equals the square root of 9 divided by 4, but it does not work with adding and subtracting, only multiplying and dividing, all right? So these are some general rules involving radicals, which we can write out here. So root A times root B equals root AB, as long as A and B are greater than 0. And root A over root B is root A over B. Again, where A has to be greater than or equal to 0, and B is greater than 0. Because you can have 0 in your numerator, and that equals, then it'll be, the whole thing will be 0. But you can't have 0 in the denominator, ever. I have a toolkit page for this that I'll show you in class, okay? All right, so let's state whether these are true or false. I'm going to pause the video and try these and then check your answers, okay? Hopefully you got all those 3 right. Let's do example 6. Again, pause it, you try it, and then check your answers. Okay, there's the answers to example 6. It's a really good idea when you're learning these rules to show these steps that I've done for C and D, because that does help you remember the process by which you got the answer. If you just do it, go right to it, then you tend to not remember the process as well. Okay, this last one, we're going to express this as a product of radicals. And so for 77, there's only one way to do that. That's going to be the square root of 7 times the square root of 11, because that's the only factors that 77 has. For this one, you could do square root of 9 times the square root of 3, or the square root of 3 times the square root of 9. A couple of ways you can do that. And this one, again, I'm going to do this as it's the square root of 4 times the square root of 10. And I did it that way deliberately because I picked this 4 as a perfect square and 9 as a perfect square, which you'll find out later is makes things it's really helpful and handy. But there's other ways, like this could be root 2 times root 20, or root 20 times 2, whatever. There's a few ways. Okay, That's it for the video. Go ahead and finish up the rest of the assignment and let me know if you have any questions. Bye.